Okay, guys, for some reason, Miro program is not working, so therefore I'm gonna use the text file to explain the goals of this session. Hello, everyone. This is our third class in CS224 course, and today today's goals are going to be explain the table with the C code. I'm gonna explain this table and how to use it to translate a C code. This is not a part of the class, but I thought it's gonna be so important because you need to know how to use the registers in the right place in order to get good points, I guess, in the labs and stuff. And then I'm gonna explain what are pseudocodes in Mips, and I'm gonna finally explain one of the labs questions with an answer, of course, with an answer key. So it will like open a new areas in your brain to understand how Mips work. Okay, now we have a C code in front of us, and I'm gonna explain it very easily. We first of all initialize an integer, and it's called number1, and we have a function that we access, which is math equation. So this math equation takes a parameter, which is gonna be 10, and then we create another variable inside it, and it's called 20. So basically, we're just gonna call the parameter, which is 10. We're just gonna equal it to 10 multiplied by 20, so number is gonna be 200, and then we're gonna return it to result. So now result contains 200, and when we print it, it's gonna give us number one, which is 10. It didn't change because we didn't send the reference. We just sent a copy of number one, and therefore number one stays the same. It didn't change, and the result will be 200 as we said. As you can see, C out number one is 10, and C out result is 200. Now, as you can see, I have my Mars program in front of me, and I have the code that I wanna write in assembly. And as soon as we start, remember, we always write dot. What's going on? Okay, as soon as we start, we do dot data, not dot data, and then dot text. Cool. And now we can start doing our business. So basically, I'm just gonna take this code and start with the function, which is called math equation. So I'm gonna make a function, and in order to make a function, you need to make a label inside the text area. So basically, I'm just gonna go here, and I'm gonna just make a label called math equation, and this means, and of course, like to our points, and this means now I have a function. Now this function takes a parameter, right? I'm not gonna go into the code right now. I'm not gonna go to this code right now. I'm gonna leave this code, and I'm gonna start my main function. And in order to start my main function, I'm just gonna write main.points. And then I have number one equal 10. So basically I'm gonna use the registers, and you can use whatever registers you want, either temporary, either saved one, but I would like to use inside the main, I would like to use saved registers. So basically I'm just gonna write load immediate is 0, 10. And this means is 0 equal 10. So easy, not a big problem. Next, we have integer result equal math equation number one, which means we're gonna have a register that's called result, and this result is going to be the result of our function after we sent our function, which we sent a parameter to it, which is number one. So basically, what are your parameters gonna be, and how do you send them? You're gonna put the parameters that you want to send to a function to argument one, not argument one, sorry, to arguments, which is a0, a1, a2, a3. Pick whatever you want. I'm gonna pick a0 because it's empty right now. So basically, all I'm gonna do is move a0 s0, which literally means move contents of S0 to A0, which is also, you can say, A0 equal to S0. I hope it makes sense, because A0 is going to be the parameter that I'm going to send to math equation. That's number one. Number two, now my parameter is ready. Let me remove everything so it's easier to explain. Now my parameter is ready, which is A0. I need to go to the math equation. And how to go to the math equation? You're just gonna simply write jump register. What does this mean? It jumps to statement. No, I don't want to jump register. I want to jump a link. What does this do? It jumps to the register you want. It jumps to the label you want to go, and it remembers the place that you jumped from. So you can go back to the place that you jumped from in order to continue the following code. I'm gonna explain everything right now. You don't need to worry. So jump and link math equation. math equation. And what does this do? Jump to math equation label and come back here when you are done. You know what? I'm just gonna delete the label so you can read the whole sentence. Jump to math equation, which is this part, and come back when you are done with whatever in math equation. Cool. Okay, now let's start the code which of the function math equation. So I have I have a parameter, and this parameter we're gonna take it from a0, right? Because we said a0 is my parameter. So basically I'm just gonna take the a0 and I'm gonna put it to one of the t registers because it's temporaries. As soon as I'm done with the function, I need to make these to reset these temporaries to the numbers that they have been before entering the function. And all of the temporaries I have from t0 to t7 are 0. Therefore, I'm just gonna use them in this equation, in this function, and as soon as I'm done with this function, I'm gonna reset every temporary I used so far. So load immediate, no, sorry, not load immediate, move a0 to t0. No, sorry, my bad. t0 to a0. And this means t0 is equal to a0, which is equal to 10. I guess, yep. Now, I'm gonna, sometimes you don't need to move the parameter, you can use the parameter as it is, but maybe in the future you will have like a lot of math equations and stuff in the lab that you have, so it's better to move the parameter into t0, because into one of the registers. Maybe we will ask you to print, let's say add I t0 t0 t0, right? Or no, let's say a0 no, sorry, a0 a0. Okay, that was a bad example. Let's go back. Let's just do the program. But yeah, hint, always move your parameters to registers and know what are these registers. So now my t0 is it contains 10. Next, what do we have? I need a register and it should be containing 20. So all I am gonna do is load immediate. I'm just gonna do it in a better line. Yeah, load immediate t1 20. And this means t1 is equal to 20. Now I want to multiply 20 with number 1, and I want to put it in number 1. So basically I'm just gonna go here, I'm gonna write multiply, right? Multiplication without overflow, and I'm just gonna write the following, which is t1 t oops, sorry, it's not t1, it's t0, because I want my answer to be in t0, right? t0 multiplied with t0 multiplied with t1. So basically this means t0 equal to t0 times t1, which is equal to 20 times 10, sorry, 10 times 20 equal to 200. Yep. Am I done? No, I'm not done yet. I want to return the number, and I want to go back. I want to return the number. Let me delete everything so far. Yeah, I want to return the number that I got, which is 200, and I want to go back to this line of code in the main function. And how to do this? After you get your answer, now number is 20, right? We're gonna move the 20 to one of the V registers. As you can see here, we have A as arguments, and V we have the values for function results and expression evaluation. So as soon as you are done with a function and you get your result, you need to move it to one of these two registers, either V0 or V1. Maybe you can have like two returns in an assembly function. So one of the return is going to be in V0 and the other one is going to be in V1. And this is good thing about assembly. Like in other codes, you can just return one thing. In assembly, you might be able to return two things if you want in one function. So basically move t0, no, not move t0, sorry. Set t1's to contents of t2. Yeah, v0, t0. And now v0 is equal to t0, which is equal to 200. Now we have our result in v0, and now we can go back to the function. But remember, as I said earlier, as soon as you finish a function, reset everything except the even the even the parameter. Reset the parameter to the thing it was before moving, before coming to this function. So basically, I'm gonna write t0 load immediate t0 0, and this now makes t0 equal to 0, and do the same as well with t1 load immediate t1 0, and now t1 is equal 0. So now I have resetted my temporaries. Did I change my a? No, I didn't change anything in my a, so a is still 10. We're gonna debug this program as soon as we finish as well. My a is still 10, and now we can go back. And how to go back from the place we jumped? Remember, we jumped from this place, math from jump and link. So how to return? Just write jump register, and then write RA, and this means jump back from the linked, from jump back to jump and link, jump back to the next line. You know what? Jump back to the line after jump and link operation used earlier. It's just okay, cool. In order to see it. So what does this mean? Jump JR, let me write it here. JR is jump register unconditionally, which means jump to one of the registers, right? And here are my registers, and one of them is RA. What is RA? RA is called return address. RA, let me write a comment here. RA stands for return address. And you might be wondering, how does this return address bring us here? So basically, jump and link, what does it do? Jump and link, it jumps and link the place that you jumped from. So it jumps from here to math equation, right? Because you want to jump to a math equation. And it links it by putting the address, or no, the PC counter, by putting the PC counter of this line into register RA, which is return address. You're gonna see everything when I assemble the program. But basically, when we just write jump and link, we jump to the label we want to jump, and then we return the address. We put the address we want to return to in return address. And therefore, when I write jump register RA, it's just gonna jump from here to here, and now we can continue our program. Right? Now our function is done. So basically, I like to write this as well. Also, it should be in comments in order not to create any mistakes. Yep. Basically, I just like to have these between each function in order not to make mistakes in the future and for better readability as well. You know what? Let's just write this at the end of the program. Cool. Now we are done with the function. Sorry. Now we are done with this function, right? Now we are done with this function. Let's just go back and print these two. Now we're done, right? We're coming back from this function and we're gonna start writing these two, number one and result. I don't need this program anymore in this picture because like you know what it's gonna do next. So basically I wanna print the number, and our print number is 10 is 0. So basically all I'm gonna do is move a0 is 0. And this means now a0 contains s0, which is equal to 10. Load immediate v. I was about to do a huge mistake. Remember, our result is in v0. From this function, our result in v0. I want to save this v0 before changing it. So all I'm gonna do as soon as I'm done, I totally forgot to do this. Move s1, sorry, v0 s1. No, v0 s1. And now S1 is equal to V0, which is the result of math equation, which is equal to 200. Cool. Yep. Now we can use V0 as we want. Now we want to print S0 and S1. So what do? Load immediate no, move a0 is 0, and now, sorry, yeah, is 0 because I want to print the s0 at the beginning, first. So basically a0 is gonna be equal to s0, and now we load immediate v0 2, and then we write this code y2. Basically, if you just go here in help and you go to this calls, you want to print an integer, right? So v0 should contain 1. So sorry, it's not 1, it's not 2, it's 1. Yes. And you wanna, your a0 contains the integer that you wanna print. So a0 is now equal to 0, v0 v0 equal to 1, and this call means print what is inside a0. So now we're gonna print 10, and I'm gonna copy the same thing. I'm not gonna change anything. I'm just gonna copy the same thing and put it here. Cool, because I'm gonna do the same steps with the minor change. S0 now is gonna become S1 because now S1 is the result of math equation, right? So now A0 is equal to S1, and V0 is gonna be 1 because we wanna print an integer, and this says print what's inside A0, which is now 200. And now it should be printing this um, 200 as soon as I'm done with this. And finally, I want to teach you guys something. As soon as you're done with and you want to finish execute, so as soon as you finish this line, the program will continue and it will start move t0 a0, but we don't want to access the function anymore. So basically we're just gonna write liv0 10 and syscall. And what does this do? Terminates the program, and now we're done. All I'm gonna do right now is just gonna copy this and put it here. So you know what, I want to try something. If I write it like this, will there be mistakes? Yep, there's a mistake. Yeah, it should be in the comments. Yep. So now I know that this is a main function, and after this one is another function, and it's called math equation. Maybe I need to use a function in the future, so therefore I put another line. Let's trace the code. Let's see if it even brings us the right answers or not. Yep, we have 10, 200, but it's not in a new line. So basically, in order to have it in a new line, you might just add here a label. Let's call it NL, stands for new line. Dot word, no, dot ASCII, it should be dot ASCII. Then I'm just gonna write /n. I don't really know. I think this one. Yep. And then between this printing and this printing, I'm just gonna do the following: load address a0 with NL, load immediate v0 4 for printing a string, syscall, and this means, oops, print a new line. Let's see. Yep. Oh, let me clear it. Let me start from the beginning. We run it, boom, boom. As you can see, 10, 200. And now our program works perfectly. Let's, for the sake of understanding the code, let's go line by line. So I'm going to assemble it here. I'm gonna go line by line. So basically, we have load immediate s0 10. And what does this do? It just put 10 to s0. As you can see, the comment is here in order for you to read it. Let me close this. Let me extend this so you can read all the comments we have in this program. We go, and now S0 contains 10, which is A in hexadecimal. So basically, I taught you I explained the code I explained how to use the table with the C code. Now let me explain the pseudocode in Mips. Basically, move is a pseudocode. Why? Because we don't have anything in our in Mips or like in assembly language. There's not a code instruction called move. It's just add u. What does add u? Let's write it here for just add u is addition unsigned with overflow. So basically, it's gonna just add numbers that you give it to it. with 0. How? Go here. It says add 4. And what is 4 here? If we go to register, we have 4 here, and 4 here is A0, as you can see here. 4 here is A0. And then it says S0, which is 0, right? 0, 0. And what does this do here? The constant value 0. So basically, we're just adding S0 with S16, with number 16, and number 16 is S0. So sorry, number 16 is S0, and S0 contains 10. So basically 10 plus 0 is going to be 10. And then we're going to assign it to 4, which is A0. So basically A0 is um, A0 is going to be 0 plus 10. And now it's going to be equal to 10. So basically A0 is going to be 10. Next, boom, 18 is 10. Now jump and link is not a pseudocode. It's normal instruction because as you can see, JAL, nothing changed. Move. Oh, you know what happened? We said JL stands for jump and link. So therefore, as soon as I press this, we jumped from line 11 to line 32. What is line 32? Line 32 immediately, we jumped from here, right? Line 32 immediately starts after math equation. So basically, we just jump to this function in order to do it. Move is, as I said, move is a pseudocode. Load immediate is another pseudocode. Like, look, it says here load immediate. Here it says add IU, so it's a pseudocode. Multiple is not a pseudocode, it's normal instruction move. We said it's pseudocode, load immediate pseudocode, load immediate is another pseudocode. Jump RA is not a pseudocode. It's not a pseudocode, it's a normal instruction. As you can see, JR. And then we go back to the place we jumped from. So we jumped from here, right? We jumped from line 11. So basically, when we go back, we're not gonna jump again. We're just gonna start from the instruction that's after jump and link. So basically, we start from line 13, and as you can see here, line 13 move S1 V0. Yep. And therefore, we just keep going till the end of the program. As you can see here, we print 10. As you can see here, we print 10, and we're gonna do the same here. We're printing Syscall V0 to 100. That's everything for today, I guess. Thank you so much for watching. Hope you have learned and enjoyed. See you. Yeah, totally forgot. Before I end this class, I want to say a pseudocode might be one line of code and might be multiple line of code. As you can see here, we have load address A0NL, and we see that NL is something from the data. So basically, we take something from memory and we put it in A0. And as you can see here, we don't use load address here. No, we use two codes, which is load upper immediate and or upper immediate. And I'm gonna explain this in the course, maybe in the 5th or 6th or 7th class, not in this class. But you need to know that when you load address something from the memory, it's gonna be written in two codes. First, load upper immediate. Second, order immediate. And it just can be done in one line of code, thanks to the programmers who updated Mars to make it like easier for us to use. So basically, load address is just made of two line of codes: load upper immediate or upper immediate. I think now I can say thank you so much for watching. I hope you have enjoyed and have a great day. See you.